Okay, sorry about that interruption. So, number 4, let's go back. Let's reread what number 4 says. It says a rectangle has a length of 25x cubed and a width of 5x squared. Find the area in square units. So what we're going to do is to find the area of a rectangle. Sorry, I said square. Of a rectangle, it is A equals BH, little b, little h, which is base times height. Now your base is 25x cubed and your height is 5x squared. So what you're going to do is you're going to substitute the number into the equation. So we have A equals 25x cubed times 5x squared. Now what we're going to do is we're going to solve. When we're solving, you have to solve with the properties that you have known. So if you have 25 times 5, it is 25 times 5. There isn't anything different with that. And then you have x cubed times x squared, which actually, with your laws of exponents, you will say 3 plus 2. So the area would be 25 times 5 is 125. And then you have x to the 5th power because 3 plus 2 is 5. So it's 125 x to the 5th units squared. Okay, next let's look at number 5. Number 5 states, simplify m to the 5th r squared over m squared r cubed. Now when you're multiplying exponents, variables with exponents, we actually add them, okay, or we'll multiply them. But when you see a main division, that means we're going to subtract. And we subtract the numerator exponent by the exponent in the denominator, but you have to remember their bases must be the same. So you're looking at the m's together and you're looking at the r terms together, all right? So we're going to say m 5 minus 2 and r 2 minus 3. All right, so we have m, we're going to solve or simplify. 5 minus 2 is 3 and r to the negative 1. Now with the laws of exponents, we're not supposed to have any negative exponents. And the only way to make a negative exponent a positive is to multiply by the reciprocal, okay? Now the reciprocal simply means to flip the fraction. Well, there's technically a 1 underneath this, all right? So what we're going to do is we're going to flip this fraction, and that is going to put the r in the denominator, which makes the exponent positive. So your answer would be m cubed over r. Number 6. Express 0.00024 in scientific notation. So this number right now is in standard form. Since the number is between 0 and 1, we know, let's put that our exponent is going to be a negative. So I put that little hint right there that our exponent is going to be negative. If this number was larger than 1, we would have a positive exponent, okay? So as we're trying to take a standard form number into a scientific notation, we have to move the decimal so that there is only one non-zero digit to the left. That means the only digits in front of that decimal can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. That is it. There cannot be another number in front of the decimal. So here we go. How many times are we going to whoop it over? 1, 2, 3, 4, 5. I have a number to the left of my decimal, so I stop. So I have 2.4. Now remember, you always put the times 10. And how many times do we move it again? 1, 2, 3, 4, 5. But my exponent has to be negative because it is a number between 0 and 1. Okay, let's move to number 7. Number 7 says evaluate 7 times 10 to the 8th power and 2.4 times 10 to the negative 4th power. Okay, so what I'm going to do, here's the trick. You use your calculator. you're going to type it in just the way you see it. Let me move my calculator over here so you can kind of actually see the buttons that I'm pushing. 7 times 10. When you need an exponent, you don't forget you have to use this caret. To the 8th, we're going to close that parentheses. We're going to open the next set of parentheses and put 2.4 times 10 caret. Now, your negative sign is down here. Don't forget. Negative 4, close parentheses, hit enter. Okay? So it gives the number to me, which is 168,000. All right. Now, this number has to be in scientific notation. Well, not a problem. Once we get the standard form, we can move it into scientific notation. Now, this number is greater than 1, so I know that my exponent is going to be positive. There's a decimal at the far side of this number, and I need to move it until I only have one non-zero digit in the front of my decimal. 1, 2, 3, 4, 5. 1.68 times 10 to the positive 5. The exponent only is how many times you move your decimal. That is it. It doesn't say how many zeros there are. It doesn't say how many numbers there are going to be. It simply tells you how many times you move the decimal. Okay? All right, so now let's look at number 8. Number 8 says to evaluate, I guess I need to write that. Evaluate 16 to the 3/4 power. Once again, you put in your calculator. You say 16 to the, and the caret, you're going to open parentheses, and you're going to say 3 divided by 4. Hit enter, and the answer is 8. Number 9. Solve 3x plus 2 equals 81. All right. In an equation like this, what we have to do is we have to get base numbers and exponents, okay? And you have to have the same base. You cannot work with exponents unless your bases are the exact same. So what I would do is we see that the base right here is 3. So we're going to leave 3x plus 2, and then we're going to figure out 3 to the power of what is 81. Now, you can go in and you can say 3 to the power of 2, 3 to the power of 3, not there yet, 3 to the power of 4, 81, okay? So you have 3 to the 4th power. Now, 3 to the 4th power is the same as 81, so I haven't changed my equation, all right? I've changed the form, but I have not changed my numbers. It is still a balanced equation. Now, once you have your bases the same, you can just look at the exponents to solve it. Well, now we have a simple one-step equation. X plus 2 equals 4. What you do to one side, you must do to the other. You always want to isolate that variable on one side. X equals 2. That's it. Number 10. Number 10 says, which equation corresponds with the graph? All right. So I did have students earlier today that they were asking me different ways to solve this. And honestly, you're given the tools, use them, okay? You're given a calculator. Let's just input this. So we're going to say 2 to the x power, okay? So here, let me clear that out so you can see what I'm typing here. We're going to type a 2. We're going to hit the caret, and then we're going to hit our x, okay? Plus 2. Now all we're going to do is we're going to hit graph. Does that graph look like this graph? Okay, the answer is no. We mark off F. All right, so let's go back to y equals. You want to clear out that equation. And let's type this in. Now make sure you're using your parentheses. Open parentheses, 1 divided by 2, close parentheses, to the x power minus 2, and hit graph. Okay, now that one's just going the wrong way, isn't it? Okay, so it can't be G. So go to y equals, clear it out again. Let's look at this next one. 2 to the power of x minus 2 graph. That looks like it, okay? It's very close. So what I'm gonna do is I'm gonna put a little dot to it because it looks like there's more. If you see that here it crosses at 1, it actually crosses at 1 on your calculator. This is just a more, it's like a zoomed in version, magnified version that it doesn't look as closely related, but you can tell it's the exact same slope on it. So let's go ahead and look at the last one because, you know, it's fine. You have a calculator. Let's double check what we have. 1 divided by 2, close parentheses, to the x plus 2, and hit graph. There you go, and that's going the wrong direction, so we know right now the answer is H. Okay? What is the y-intercept on the graph shown? Well, the y-intercept is where the line or where your graph crosses the y-axis. Well, where does it cross the y-axis? It crosses the y-axis right there at -1. Okay, so let's look at number 11. Number 11 states, a chess tournament starts with 16 people competing. The exponential function y equals 16 times 1/2 to the x power describes how many people are remaining in the tournament after x rounds. How many people are left in the tournament after 2 rounds? Okay, well, we have some important information here. Well, number 1, we have our equation. Number 2, it says x rounds, and then it tells me that x equals 2. Okay, because if rounds represents x and there's 2 rounds, x equals 2. So what we're going to do, we're going to use our calculator. Okay, and we're just going to type this in. 16, open parentheses, 1 divided by 2, close parentheses, and instead of putting to the x power, we're putting squared. And you can hit this button right here. It says x squared, and that automatically puts a square there, and you hit enter. How many people were left in the round? 4. So after 2 rounds, only 4 people were left. Okay, let's look at the next one. Determine the amount of an investment if $1,000 is invested at an interest rate of 8% compounded quarterly for 2 years. Remember what I told you. Anytime you have a word problem that has the word compounded, we're going to use compound interest. Okay? Every single time. That will never, never, never change. So let's, I'm going to get a piece of paper here and we're going to write that compound interest down. And we're going to gather the information that we need. Let me fold this so that we can get everything on the same screen. Okay. So here, let me write number 13. All right. So first we're going to write our compound interest equation down. A equals P, open parentheses, 1 plus R divided by N, close parentheses, to the N times T power. Okay. So let's write down a few things. Well, P stands for principal. Principal amount or your initial investment. So our initial investment was $1,000. Okay? So we got that part. It was invested at an interest rate of 8%. Well, R is your rate. This is a percent, but we must change percents to a decimal. So you have to drop your percent sign and move your decimal 2 places to the left, 0.08. Now it says it was compounded quarterly. That's very important because N represents how many times this investment was compounded in a year. Well, quarterly means 4. So now N equals 4. And how long did we have this investment?